this is Nishant and I will be taking you through the initial process and setup of our project, a smart kitchen. So, the task assigned to us is the following. We first replace the normal jars in our kitchen with smart jar and we turn a regular cylinder into a smart cylinder. Our goal is to inform the user about the present status of the contents inside the jar and the cylinder and send an SMS whenever the jar or the cylinder goes empty or whenever there's gas leakage. So for this project, we're not actually using any hardware and take actual readings. So instead, we assume a scenario and apply that in our software such that it contains all the possibilities. Let me take you to how it's done. So this is the IBM Cloud. Okay. This is you have the IBM platform. So I go to my resource list. And under services, I have the Internet of Things platform. If you click this, you get this, right? This is the Internet of Things platform and you launch it. If you launch, you'll come here. This is the section where you add devices. I've already added my device. This is my device. My device ID is 12356 and my device type is Raspberry Pi, right? And these are my credentials and device informations. Now, let me take you to the Python code and show you how we connect it to this platform. Right, this import IBM IoT f.device. This is the library that we use to connect our code with our IoT. Now, the organization, device type, device ID, auth method, and auth token are our device credentials. I store every device details here and put it in a JSON format and call it device options. Now, I put this JSON inside a function called IBM IoT f.device.client and get this variable device flag. I also have an exception. In case I made a typo somewhere here, it will tell me where I made the error, the exact error. Okay. Then I connect my code to my device. So as I said, since we're not actually using any hardware to demonstrate, we assume a scenario which contains all the possible outputs. We assume weight of the jar to be 1500 grams. We know the weight of the cylinder is 30 kgs. We must calibrate our device such that it only takes the weight of the gas inside the cylinder and let us know if it's empty. So we take the weight of the cylinder to be 15 kgs, that is the gas weight only. Now these two variables, jar weight and cylinder weight, contains the weights respectively. And the fan and leak variables are nothing but the exhaust fan to state whether it's on or off and the leakage if it's leaking or not. Right? I'll talk about this later. And we also have two variables, cyl empty, cyl and jar empty. These are used as flags. This is to make sure when we send the alert SMS, the alert is sent only once until reset. So this prevents us from resending the message every time the sensor detects empty, 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 right? So this is our actual program. While true, we assume the cylinder to be 0.01 times every loop. This is just a demonstration, guys. We assume the gas is used by the stove out of the cylinder 0.01 times in every loop. Okay, and also for our jar, 1 tablespoon is 14 grams. Hence, we reduce 14 grams every time we simulate taking sugar out of the jar with a tablespoon. Right. So this is the if-else conditions. This is nothing but to show the status of the contents of the jar or the cylinder. We just define conditions, right? If it's less than 5 kg and greater than 0, it's low. If it's less than 0, it's empty. If it's between 5 and 10, it's medium, like that. And this scenario is where the cylinder goes empty or less than empty. We set that variable to 0 and we change the status to empty. And this is the code to alert the user through an SMS, right? This is a flag as I stated. When this is equal to 0, it sends an SMS. After that, it turns to 1 so that it does not keep repeating the SMS. Okay. So this is the message, actual message I'm sending to the user. And the number is added here. So the same goes for the jar. We define the weights and the statuses, and we also send this SMS. The content of the jar is empty, refill to continue usage. And we also add the number here. After that, since we are not using any hardware to detect the gas leakage, we simulate to show this condition. We assume that after 50 loops, the gas starts leaking and we alert the user by sending an SMS, right? So as I said, the I equals 0 is just to simulate the gas leaks after 50 loops, okay? Just to show that this condition is also taken care of. So if there's any gas leakage, we can see that fan is also turned on and leakage is turned on and the gas leakage detected. Check immediately, message is also sent to the user. Right, now this is the part where we send the details to the IBM platform. So again, these are all stored as JSON format in our variable data. And you can see round cylinder weight comma 2. I'm rounding off the float values to be two decimals, right? Now again, publish event is a function that publishes the data to the IBM platform. My event name is Smart Kitchen, the format is JSON, and the data is data. QoS quality of service I've set it to 0. And my onPublish, I want to print this statement every time it publishes, right? So I can see that in my Python code to make sure that the data is published in the IBM platform. So if not connected to IOTF, then I have a regular interval that is time sleep, and then I'll show you by running this code. Right, it has started. See, published cylinder weight is 14.5, cylinder status high, gas leakage is off, jar weight this, status, fan status off. If we go through the loops, every time it's printing. Now we can also see that these data are published in our platform. We go to recent events. You can see that the gas leakage after 50 loops has been turned on and the fan status is also on. The fan is the exhaust fan, nothing else. And we see that the cylinder status is changing, jar status is changing according to the condition we have given it. And yeah, now the jar status is low. And now the cylinder has gone to low condition. Now this jar is empty. Now this is a case where it sends the user the SMS, right? SMS sent successfully. Now same for the cylinder. After it drops or goes less than empty, it sends the alert to the user. See, as I said, it's reflecting in the platform in the recent events. You can click and view the JSON format. This is the details, and I can also show you the boards, the cards, the values. Give it a second. Yes, right. Now a cylinder has dropped to empty and the jar weight has been empty. That's why you're not seeing any readings here. And the status of each are displayed here. So this is our Python code connecting to IBM part. I can actually show you the SMS that I received, the alert. Yes, I can show the SMS. Thanuja, are you there? Thanuja? As you can see, the gas leakage is detected. Check immediately. Your cylinder is empty, and the content of the jar is empty and refilled. So we're done with our part. We'll now go to the web app, UI, and the mobile app. So web app, Node-RED, Divya, proceed.
Yeah. What is Node-RED? Node-RED is used for creating web applications. Node-RED is a programming tool for wiring together hardware devices. online services in new and interesting ways. It provides a browser-based editor that makes it easy to wire together flows, giving a wide range of nodes in the palette that can be deployed to its runtime in a single block. So, this part is a workspace where we can create the design. We can take the nodes, there are inbuilt nodes. We can take the nodes from here. If we want to add any new node, we can go here and we can click on manage palette and we can select a particular library and we can install the nodes. The data of a sensor is being displayed in the command window. So to get the data, we have taken an IBM IoT device. This is the data from the IBM IoT platform. These are the functions. The function node are used to run JavaScript code against the message object. The function code accepts message object as an input and can return 0 or move message object as an output. So for everything, we are sending the message output to the user interface. This is used as a debugger. If we stop it, our data will stop debugging. So basically, this is a gauge which is used to represent the current data, and it can show from minimum to maximum range. This is the text which can be used to show the status, and we have created the graphs using charts. Now I will show you the dashboard for the Node-RED. So this displays our data. This is the gauge function for the jar weight. Now our jar weight has reduced to 0 and the cylinder weight is dropping to 0. So we have demonstrated it using graphs, and here we can show the status that the jar is empty and cylinder status is low and it will soon be empty. Gas leakage is on and so the exhaust fan is on. So again I will go there. If I want to adjust my dashboard, I can go here and I can change the settings here. Like if I want some spacing, I can put a spacer here. So this way I can edit my dashboard and I can make it more beautiful. So now to send the data to the mobile app, I have defined the function as global set. So this HTTP protocol is taking the data and it's transferring it to the function. This data we have transferred it through a URL to the mobile app. Now Tanuja will explain about the mobile app.
Yeah, so now we need to create an application.
Share screen.
Is this visible?
Yes.
So yes, now we need to create an application because so that we can get the present status of the level, that is if cylinder or jar is empty or not, if the exhaust fan is in on or off condition. We used to get the updated values, that is the current status of these things, so that we install this app and we created this app. MIT App Inventor is used to build this application. So in the screen, you can see the front end screen of the application, that is the Smart Kitchen, where in the screen, the text and the text boxes are constructed using the palette, where it is on the left side, and we use the user interface, like the table, text box, and many other interfaces to build this object. all we need is to click, drag and paste it on the screen. So, for example, when we click this text box, on the right side properties bar, we can see the background color, block, italic, so that if you want the text color, if you want to change the height, width, font size, and you can just edit it using these properties tab. And then we need to use a clock interface where this is actually used to tell us for how many seconds the values are updated, the values are shown. So on the properties bar, you can see the time interval is 1000. So that each and every second the value gets updated. So when we open the app, we can take two values at that particular time. And this is all about the front end part of the application, where the back end is this. The back end is the blocks part, where we use blocks to create the entire structure. On the left side, we see the blocks bar, where we have screen, label, all which we created in the front end. So, like when you click on the text box, you find the sub block, so that you click, drag, and then construct the block. So, as like we have the clock, so that the value updates every second, and this URL is the one where we used to get the inputs from. Like now, can you see this side? So from there we get the input. So this URL is used here, and then the following text boxes represent the plate, sticker, jar, fan, etc. And the main thing is that we use JSON text format to build this backend format. So this is all about the backend one, and the front end is nothing but the mobile screen. So yes, now when everything is over, we need to go click on build and click this app so that we get a QR code and a link. So when we like scan it or when we go click the link in our mobile, we can install the app, open and check the readings. So yes, Nishant is here to show the output of the app.
Yeah. And the URL output.
Yes. So this is how our app displays the values. See, if I run it, it's changed, it's updating. Maybe are you there?
Yeah.
No, you can also show the web UI, node thing. Show that.
Yeah.
Share and show.
Yeah. So this is the data we got it from Node-RED. This is our URL data which we are passing to the mobile application.
Show the graph part.
The screen is not visible.
Yeah, this one.
Yeah, this is the Node-RED dashboard. So the data is changing and we can see it in the
The
gauge.
screen is not visible. Yeah, now.
Right. So this is our project, and this concludes our result. Thank you for reviewing. Good day. That's okay.